Happy day, everybody. This is Orekoya Olusegun, Physics Mathematics Fundamentals on YouTube. Please, before we go into today's topic, do not forget to like, share, subscribe, and click on the notification button to have more of my video. Today, we are taking a topic concerning remainder and factor theorem of under polynomial functions. So we are still on the polynomial functions. We want to do what is called remainder and factor theorem. Now, in mathematics, you know that we have come across this line of work in mathematics. Whatever we write outside here is called the divisor function. Whatever that we write on top here is called the quotient function. Whatever that we have here is called the dividend, and here is the remainder. So, like for instance, let's say I have 5 divided by 2. Note that 5 divided by 2, we have 2 remainder 1. So this particular 2 that you will have here is called the divisor. The one on top here is called dividend. And what we have here is the remainder. So we can write this one in this format like this. This 5 is the one inside here, and the remainder, this one is here. This quotient is the one that is here, and the divisor is this 2 that is here. So that is the line of work. So this one, like I said, is called quotient function. Quotient function. What we have here is a divisor function. And then what we have here is called the dividend. And this R is called the remainder. So take note of that, because you need to have an idea of this line of force of work as we progress with our solution. Now let's solve this problem that are here. The first problem says find the remainder when x plus 4 divides x cubed plus 2x squared minus 3x plus 5. Factorize x cubed plus 5x squared minus 4x minus 20 completely. Given that x plus 1 and x minus 2 are factors of this polynomial, find the value of p and q. Factorize the expression completely. Now, before we solve that, I want to introduce us to the idea of remainder and the factor theorem. Normally, the polynomial f of x, we normally divide it with this divisor d of x. It will give us the quotient q of x, then plus the remainder function. This remainder function that is here may be a variable function or a constant function. So let's say this particular remainder function is constant. Then I can rewrite this one, f of x divided by d of x. I can write it now as q of x. Okay, this one's supposed to be divided by d of x. So I can now write that plus r divided by d of x. So if we want to make this f of x not a formula, we can multiply both sides of the equation by d of x. So f of x here, using multiply both sides by d of x, means we are going to have d of x, then times quotient function of x. Then by the time we use this thing to multiply, this one cancel this remainder r. So this is the relationship among the what I call the dividend that time. Dividend. Then this one is a divisor. This one is called quotient. And this one is called remainder. So now we want to do remainder theorem. Now let's say this divisor d of x is given as this x plus a. If divisor is d of x is x plus a, then I can write my polynomial function as f of x is equal to instead of d of x, I will write x plus a times quotient of x plus the remainder. Now, a situation whereby x is equal to minus a. If you put minus a here, the whole of this thing becomes 0. 0 times everything here becomes 0. So in that case, f of x will be the remainder. So that means that f of a f of minus a, because when x is minus a, I put minus a here, minus a here. Then let me substitute. Anywhere you see x, put minus a, plus a, q of a, q of minus a, plus remainder. So minus a plus a is 0. 0 times this one will become 0. So f of minus a is equal to remainder. So this is the remainder theorem. So what this one is saying is that when we use this x plus a to divide polynomial f of x, then function of minus a will give us the remainder. That's the remainder theorem. If this factor, if it has been x minus a, then what I have here, if I have x minus a here, then I will say let my x be a, so that this one can become 0. We are still going to have the remainder theorem. Now, from the remainder theorem, we move down to factor theorem. If f of this minus a, instead of giving us r, if it is 0, then we say that this particular factor that we use to divide, this particular expression that we use to divide is the factor, is a factor of f of x. This is the introductory aspect to the solution of this problem. This is the line of work for remainder and factor theorem. So my next video will be to the solution of this problem. Thank you so much. Please click on the next video. Thank you. Have a nice day. Bye. You have done that?
No, I haven't seen.